Hello, Luke. Welcome to Lesson 71. So today we're going to be talking about two things, trinomials with common factors, and then something completely unrelated, subscripted variables. All right? Both of these are very straightforward concepts. The first one, trinomials with common factors, is really just an extension of what we've already learned. And then subscripted variables is very straightforward. So should be a fairly simple day today. And let's go ahead and get started. So to begin with, let's just look at this problem over here. You should see this and it should look familiar to you. We're just trying to factor this. And this is something that we have been practicing for a while now. And I think yesterday we even did some work on this. And what we'll be doing is trying to break this up into a binomial, right? A product of binomial or product of monomials here. So we have our set of parentheses, and we've been working on how to decide what goes where. And we know that this case would be x and x. Plus would indicate that they're both the same sign. It's this sign, and it's a plus. And then you'd have to do your factors for the 2, and we would find out that it'd be 2 and 1. All right? So that would be how we would factor this trinomial right here. Okay? Today, we're going to take that one step further, and we're going to talk about really the step that we should be doing even prior to this step. Okay? So let's just jump to this next problem. If I have x to the third plus 6x squared plus 5x, and I'm told to factor this, the first step is actually always to look for common factors among the terms that are given. So we have 3 terms here. Let's try to find some common factors, if there are any. And that's so important. I'm going to write that down, actually. This is the first step when factoring. When factoring. First step, number 1, is to look for common factors. Okay, that's the first step. And then only after that step would we go on to say this step, looking at this trinomial and trying to break it up into binomials. Okay, so this is always the first thing that we are going to do, look for common factors. Okay, so in this particular situation, or with this particular expression, I have x to the third plus 6x squared plus 5x. I'm looking for common factors. Now, these terms, again, are made up of coefficients as well as variables. And so if we start by maybe just looking at the coefficients, we would see that this one has a coefficient of a 1, right? This one has a coefficient of a 6, and this one has a coefficient of 5. So if you think of those 3 numbers, 1, 6, and 5, do they have a common factor other than 1? Because everything will have a common factor with 1. But other than 1, do they have a common factor? The answer is no, they don't, right? There's nothing that can go into 5, 6, and 1 other than 1. All right? So there is not a common factor amongst the coefficients. All right, so there's really nothing that we can factor out there. Now, let's look at the variables, though. So the variables, we have x here, and we have an x here, and we have an x here. So there is an x in every term in the expression. All right, so if there's an x in every term, well, that means that x could be factored out. All right, and we've done some work with this before. It's kind of the opposite of the distributive property. All right, so if every term has an x, you might ask yourself, how many x's are common between all of these terms? Well, the most we could have that are common would be 1, right? Because there's only one x right here, right? And because of that, this one is not going to have a factor of, let's say, x squared, for example. It can't, in a way, you could think of it as it can't fit into this term. Only x can fit into this term. Okay, there's only one x. So that means we can factor out one x and no more from these 3 terms. So if I set my x out, and then if you recall, we're going to set up a set of parentheses, and we're going to take each term and rewrite it only without this factor, this common factor of x. Okay, so an x to the cubed if we remove an x from that, we now have x squared. And then we have plus 6. Now we have x squared here, but we're removing an x, so now we only have x. And then we have plus 5x, but we're removing the x, and we're getting just 5. Okay? Now, this can be easily checked by using the distributive property. If I take this x and I distribute it through every term, I can easily see how that would get me back to where I started. Okay? It's a good little check. All right? That's all we're doing. We're just undoing the distributive property. So we pulled out an x. That is what I mean by this step number 1. We just did step number 1. Okay? We found a common factor among all the terms, and we pulled it out. Okay? Now, once we've done that, we can look at what's left over and see if there are any other tools in our tool bag that we can use to factor this. And if we look at it, we see that in the parentheses here, if we just kind of ignore everything else and just focus in on these on the set of parentheses, we could see that, okay, here we have a trinomial inside. Okay? And as we've been studying, trinomials can sometimes be broken up into binomials. Okay? So let's try it. So if I take this trinomial and set it up as a set of binomials, or a binomial, we could have the x's, which would be distributed through as the first term. We have a 5. Well, let's do the signs. Remember all of our little tricks. Plus indicates that the signs are going to be the same. This plus indicates they're going to be a plus. So we have a plus and a plus. And then the 5, we have to think of factors of 5 such that they will add up to be 6. Well, the factors of 5 that would add up to 6 would be 5 and 1, because 5 plus 1 is 6, and 5 times 1 is 5. So we have a 5 and a 1. And if we wanted to check this, we could use FOIL to multiply this back out, and we should get this original trinomial. Okay, and you can even do that in your head. X times x, x squared. The outside, 1x. The inside, 5x. Add those two together. 5x and 1x is 6x. And then our last, 5 times 1 is 5. Bingo. There, it checks out. All right, so this inside trinomial can be broken down into this binomial, and we can't forget about this x. Now that we've worked out the inside of the parentheses, this x still needs to come down next to our other two factors here. All right, so that just moves straight down. So in the end, we can take this trinomial and see that it is factorable, and it would factor into this expression, x times x plus 5 times x plus 1. Okay? So fairly straightforward. Really, the only new thing here is before you try to factor this into binomials, you want to first try to factor out anything that's common amongst the three terms. Okay? So let's try another one. Here we have one. And you know what? Why don't you pause the video? Give this one a try, and then we'll do it together. All right, so we have 4bx cubed minus 4bx squared minus 80bx. Okay, so again, the first step, let's look for common factors. So let's look at our coefficients. That's usually a good place to start. I have a 4, I have a 4, and I have an 80. All right, do we have anything that's common between a 4, and an 80? Well, sure, 4, right? Because 4 can go into 4, and of course that means it can go into this 4, and 4 can also go into 80. All right, so 4 is a common factor of all three of these numbers. So that means I can factor out a 4. So I'm going to set that 4 down here. Okay, now before I factor it out, let's look and see if there's anything else that we can factor out. So now let's look at our variables. And in our variables, we have a b here, we have a b here, and we have a b here. Yay! So that means we can factor out some b's. How many? Well, they're all b to the first power, so we can only factor out one b. Okay? Anything else that can be factored out? Well, let's take a look at our other variables. We have, excuse me, we have an x. in this term, we have an x in this term, and we have an x in this term. So sure enough, we have x's in all three terms. So how many x's could we pull out? Well, this one has 3, this one has 2, this one only has 1. So the only thing that's common between all three is just one of them. So we pull out 1x. Okay? So we have 4bx. Those are the common factors for these three terms. So now we can go ahead and actually do the factoring part. So we'll set up our parentheses here to hold everything else. And we're going to take this 4bx squared and we need to divide out this factor 4bx. All right. So if I take 4bx cubed and divide out 4bx, well, the 4 will just divide out with a 4, and that's just going to give me a 1. The b's are just going to divide out and give me a 1. And then x to the third divided by x to the first is just going to give me x squared, right? X to the third divided by x is just x squared, right? Okay. So we have just simply an x squared for our first term. Now our second term, it's we have our negative sign. We're going to leave that in there. The 4 divided by the 4, that's just going to give me a 1. B divided by the b, that's just going to give me the 1. X squared divided by an x, that's just going to give me x. Okay, and that's all I have. Moving on to the negative 80. Now negative 80 divided by 4, well, that's a negative 20, right? And then the b divided by b, well, that's just a 1. So when I take 20 times 1, it's still just 20. And then the x divided by the x, well, that's just a 1 as well. So I'm still just going to end up with 20. So what I have left inside my parentheses here, after dividing out the 4bx, is going to be x squared minus x minus 20. Okay? Our first step is now done. Our second step, though, is to look at what's inside the parentheses here and ask ourselves, could we factor this any more? All right. Clearly, there are not any common factors amongst these three terms. However, we know how to factor trinomials into binomials. So that's exactly what we're going to do again. So set up our two sets of parentheses here. Whoops. Okay. And if you want, you can bring down this 4bx even now so that you don't forget it. Don't leave him behind. He's going to be sitting outside of all this. Okay. And then in our set of parentheses, we start breaking this up. So we have an x as our first term. This negative sign tells us the signs are going to be different, right? And now we have to think of what two factors of 20 would combine to give us a 1, because there's the 1 right here, right? Well, I think right away of 5 times 4, right? Because 5 times 4 is 20. And if I have, 5 minus 4, that's going to give me 1. Okay. So that's how I can get this 1. This negative here, this first negative, indicates which one of these, this 5 or this 4 is going to get the negative sign. It's always the larger one. So this sign goes with the larger one. The larger one is the 5. So that means the negative sign is going to go with the 5. And then we have the 4 with the positive. Okay. All right. This part should be hopefully pretty straightforward now. We've done enough of these where I'm hoping it's kind of second nature to you and you're able to breeze through those pretty quickly. All right. So once we've gotten to this point, it's never a bad idea just to do a quick FOIL check, make sure that we did do this correctly. X times x is x squared. Negative 5x and a positive 4x, that would be the inside and outside. Negative 5x and the 4x. That's going to give me a negative 1x when I combine them. That's where this guy is. And then the negative 5 times the positive 4 is going to give me the negative 20. So that works out when I FOIL it. All right. And at that point, we are finished. That is our factoring right there. Thing of beauty, right? All right. Let's go on to the next one. So give this one a try and see how you do. And then we'll do it together. All right, so let's see how you did. This one's an interesting one because, again, we're going to start by looking for common factors. And if you look at it, you might say, okay, well, the first coefficient, if we're looking at coefficients first, we have a -1, and then we have a +1, and then we have a 20. So you might think 1, 1, and 20, nothing here that's common except for a 1. And like I said earlier, we're not very interested in ones. So therefore, you might say, okay, nothing common. I'm not going to worry about the coefficients. And then you might look at your variables and say, well, the only variables are x's, and that's only in 2 terms. It's not in the third term. So there aren't any common variables either. So what am I to do? Well, this one is a little bit of a tricky one, only because you're not familiar with it. And once you see how it's done, you'll realize it's not complicated. But the problem is if you try to, write this as a product of binomials here, okay, you might say, well, this is weird. I've never done one of these that has a negative sign at the beginning. Okay. So what do I do? Do I have, a -x and a -x? Is that what I throw in here for my first terms? Well, no, that wouldn't be accurate because a -x times a -x is a positive x squared, not a -x squared. So then you might say, well, should I put a negative here and a positive here? And do it that way, because -x times a positive x would get me this -x squared. Well, you'd be on the right track for sure, but it does actually complicate how we find these other numbers here, what goes here and what goes here. It does complicate things a little bit because now one of them is a negative sign in front of the x and one of them has the positive sign in front of the x. That kind of, like I said, just complicates things. So the better road to go down here is to say, this does not fit what I'm used to. So how could I manipulate it so that it does fit what I'm used to? Okay? And what I'd want to do is get rid of this negative sign. That's what I don't like. That's what I'm not used to. So what I'm going to do is I'm going to factor out a -1. Okay? I'm going to factor a -1 out from all of these terms. -1 is a common factor. -1 can go into -1, -1 can go into 1. Or I should say 1. 1 is a common factor. It can go into all three of the numbers here. It can go into the 1, it can go into the 1, it can go into the 20, right? And originally I'd said, we don't worry about that because 1s aren't helpful. This would be the one time where the 1s could be helpful, because if I factor out a -1 from this expression, that'll actually remove this negative sign in front of the x squared. All right, let's take a look at how that could happen. So the question for this first term is, what's -x squared divided by -1, right? Because that's what we're factoring out. And if you think about it, -x squared divided by a -1, well, that's just x squared, right? Because negative divided by a negative is a positive. So if I divide out a -1 from a -x squared, I end up with a positive x squared, which is nice because that's what we're used to. All right. But I have to divide all these terms by a -1. So if I have a positive x divided by a -1, what would that give me? Well, that would give me a -x. So that means this term here has to change from a positive x to a -x, which makes sense because that's what negative signs do. And then positive 20 divided by a -1, well, again, that's going to change the sign to a -20. Okay, so all that happened when we divided it by a -1 was we changed the sign on all of the terms, which totally makes sense with what we know regarding negative signs. Okay, and if you wanted to distribute this back through, you certainly could. A negative times a positive x squared is going to be a -x squared. -1 times a -x, positive x. -1 times a -20, positive 20. So you can see how definitely it works. The benefit here is now we have something that we're familiar with. We now have a trinomial in the form of an x squared, then an x, and then a coefficient. And the first term is not negative. All right. So now once we've reached this point, we can take that next step and just bring down this -1 so we don't forget about him. But then we're going to set this up into 2 parentheses and break this up just the same way that we've done it so many times before now. So again, what two numbers could somehow give us a 1, right? The two factors, I should say, two factors of 20 that would give us a 1. Well, it's again a 5 and a 4, because I know that 5 minus 4 is 1. So which one goes with which sign? I'm kind of getting ahead of myself. This sign indicates that one's going to be negative, one's going to be positive. They're going to be different. This sign indicates the negative has to go with the larger number. The larger number is 5. So the 5 is going to go here, and the 4 is going to go here. And I could, double check this with FOIL if I wanted to. All right. But that is the solution. Now, you could even write this a little bit more straightforward or more simplified, I should say. And just remember that this -1 times something just means we could, erase the -1 or erase the 1, make it invisible, and keep the negative sign. So I could write this as negative x minus 5x plus 4, right? That would be a fine solution. All right, so hopefully that makes sense. That's about as tricky as it's going to get, is just realizing that you can just pull out the negative sign if you want to by dividing it by a -1. All right? Very good. Let's try another one. So again, pause the video, try this one, and then we'll do it together. All right, so let's look for common factors here. What do we see? Well, we have coefficients 3, 6, and 72. And I'm going to say, okay, great. A 3 can go into all of those. So we know we can pull out a 3. Now, I might even take a step further and say, I don't like this negative sign here because I'm hoping, maybe I'm getting ahead of myself. Let's leave it the way it is. So if I pull out a 3, what else can I pull out? Well, they're all sharing an x as well, right? So let's pull out 1x. That's the most I can pull out because this one is only to the first power. Right? So I can pull out 1x, and that's it. Those are all the common factors. So now we divide those out. A -3x cubed divided by a 3x, well, that's going to give me a -x squared, right? And a -6x squared divided by a 3x, what's that going to give me? That is going to give me a -2x. And then a +72x divided by a 3x is going to give me a positive, in this case, what? A +24. Am I right there? Yeah, 24. All right. So we have a +24 without any x. And there we go. Now, once again, though, just like the last problem, you might look at this set of parentheses here and say, "Ooh, I'd like to try to get that into binomials, but I've got this crazy negative sign here, which I'm not used to. I don't like it. How can I get rid of it?" Same thing applies. We can pull that out by dividing everything by -1. So instead of dividing everything by 3x, what I could have done if I would have recognized this in the very beginning was just pull out a -3x. Not a +3x, but a -3x. Because what's that going to do? That's going to change all these signs. So the signs will change to their opposites, and we'd end up with this. Right? And at this point, we say, oh, good. Now I don't have a negative in front of my x squared there. This is something I'm more familiar with. I can now try to take this to the next step. So we have the -3x, and then we're going to set this up into two parentheses here. Our x's will be distributed through. The negative sign indicates opposites. So one's going to be a negative, one's going to be a positive. 24. We're looking for two factors of 24 that can somehow combine to give us a 2. And I think of a 6 times 4. Well, that's 24. And then if I take that 6 minus a 4, I will get this 2. So 6 and 4 seem to work. So if that's the case, which one goes where? Well, this sign indicates that it goes with the larger one. So the largest one is the 6, so the 6 goes with the positive, right? And then the 4 goes with the negative. And if I wanted to, I could FOIL this out and make sure that that does work the way I think it does. Okay? At this point, we're wrapped up. That's as far as we need to go. Okay? Very good. Okay, very good. Now let's move on. Hopefully you have that down. Let's start talking about subscripted variables. Okay, this is Very straightforward. It's just a little different presentation than maybe you're used to. All right. So in the past, they've given you systems of equations, such as this one, and they've told you to maybe use substitution to solve for x and y. Or maybe they've told you to use elimination to solve for x and y. It's all very good. In this case, we are just going to see this in maybe a little bit of a different way. So instead of writing it like this, you're going to start seeing problems that look like this. It might be 5n plus 10n d. Oh, that's a terrible d. D. And then equals 125. And then below that, you might have, instead of an x, it's just going to be the nn again, and then plus nd is equal to 16. Okay? These kind of crazy looking variables that have, a normal variable, such as the n, and then underneath it they have the small n, these are called subscripted variables. Okay? This small letter underneath the big letter, that is the subscript. So you would read this as n sub n. All right? N sub n. This would be n sub d. Okay? It's just a way of distinguishing variables. It has no mathematical meaning right now. Okay? So n sub n does not somehow mean, n raised to an n power or something like that. It has no meaning like that whatsoever. It's just a different way of writing a variable. Okay? The reason they're introducing this right now is because later they're going to give you story problems that deal with coins. Okay? So they'll deal with nickels and dimes and quarters and that kind of thing. And they're always going to be talking about the number of quarters and the number of dimes and the number of nickels. And so they want you to get used to this this way of writing it, because they want to be able to use n to represent number, but we can't say, that n is going to represent number of dimes and number of nickels and numbers of quarters. We have to distinguish between the different n's. So n sub n is going to represent the number of nickels, for example. Okay, so that's what that's all about. Whoops, nickels. Okay, or they might say n sub d, and that's just going to represent the number of dimes. Okay, so we're still talking the number, the count of these coins, but the different sub letters here will indicate which coin we're talking about. The number of nickels, the number of dimes, n sub q would be the number of quarters, and so on and so forth. Okay? But the math is all the same. So this new system of equations, we would solve it the exact same way that we've solved them in the past. It's just now we have different variables. It just looks a little different. But there's nothing else going on here. Okay, so if they told you to solve this by means of elimination, let's say, or let's say it's by substitution in this case. If they told you to solve it by substitution, you would do the same thing that you've always done. Okay, you might say, all right, I'm going to start by, taking the second equation and solving for n sub n, and that's going to make it 16 minus n sub d. And then I'm going to take that and plug it into my top equation here, and I'm going to have 5 times 16 minus n sub d plus 10 n sub d equals 125. And then I could multiply this through, solve for n sub d, and then go back and solve for n sub n. Okay? And maybe just to save time, I won't do all the work for that. That's all review. There's nothing new there. Okay? Excellent. So real quick, we have a problem right here. And again, I just want to make sure that you understand the setup here. Let's say we wanted to solve it by, well, this would be an easy one to solve by use of substitution, because we already have it in terms of one variable being equal to something else. Okay, the n of n sub q is equal to n sub n plus 2. So that's an easy decision. We'll solve this using substitution. All right, so we take the top equation, rewrite it, only in this case, substituting in for all n sub q's, substitute in n sub n plus 2. All right, equals 290. And again, I don't think we're going to go through the math on this. This is all review. You would just simply solve this equation for n sub n, and then go back and plug n sub n in and solve for n sub q. Okay? Excellent. That's it. That's as simple as it gets right there for the subscripted variables. Excellent. All right, well, we will stop here for today and continue on this later on. Again, we will be hitting some word problems. Hopefully by that point, you'll be very familiar with these subscripted variables and it won't throw you off. All right. Good luck, and I will see you tomorrow.